So exponential functions. As you guys pointed out, those of you that don't know, some of you pointed this out, the general shape of the curve is like that. And it does just keep getting steeper and steeper if you keep going. Michael, you mentioned human population growth. Okay. Any other things you can think of that this model? Yep, that would work too. As long as there's a food source, right? Any others?
Your stress rate from middle school to high school.
Wait.
Your stress level from sophomore year to junior year.
If you have this with me, you're fine.
Yeah.
You're gonna get white spots.
I'm pretty sure that 12th grade, there's a little bit of a drawback on that. But that's a good one. I like it because it's true. All right. So how would I graph? If I want to graph an exponential, and I've never seen a graph before, can you think of any ways to do that? Yeah, okay, let's do a table of values. Lovely. And I go with my general. -2, -1, 0, 1, 2. We can move it out if we want to. What is 2 to the -2? 1 over 2 squared. Right, because it's the negative makes it 1 over.
-1 is
Right. 0. Yeah, we got that one from yesterday, right? What's 10 billion to the 0 power? 1. 2 to the 1 is 2. 2 squared is 4. Okay. Are there any negatives there?
No.
All right, so we don't have to mess with the negative y values. And if I went to 3, it would be 8, right? There you go. Easy enough. You can use a calculator to do it too.
Yeah.
I trust that you can do that because we've been through it a few times with graphing. But there will be some no calculator problems on a test, depending on, if we finish this chapter before our testing starts. Let's see that.
What does that say that?
2 weeks before spring break. Okay, I just caused a volcanic eruption. Kate, given your knowledge of families of functions, how do I move that one? To the right 3. It's paired with the x, right? So it goes opposite of the number. So we're going right 3. Same graph, just moved. Okay, how about this one?
You go up one.
Yeah, that's up one because it's separated from the x. So move everything up one. You kind of get the idea there, shifting them around. Will that graph ever touch that line? Yes or no? I heard no, 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 no. Okay, you win. What's that called? A what? Hey, somebody just said it. It's at y equals 1. Notice, right? What's the asymptote of that one? 0, 0. Okay, good. So I would say, somebody mentioned this, as x approaches negative infinity, what happens to the y value? It goes to 1. For this one, right? So we're looking at in behavior, it approaches that value of 1. Never touches it. If you put negative 10 billion in there, it'd be 1 over 2 to the 10 billion. It's still not 0. Never would. Nope. Okay. Are you okay with those?
Yeah.
All right. This value of b is greater than 1. This is a growth function. What happens if that's 1? Anybody? It's just, it's a flat line if it's 1, right? So, but this one's a growth. Yep. B. It's the base. If the base is greater than 1, we have a growth function.
So if it's 1, what happens if it's negative? Is it a decrease function?
No.
If it's 1.
Let's look at that one. The b value is less than 1, right? We have what's called a decay. Have you guys studied exponential decay before? Half-life? You've heard of half-life? Yeah, that's what this is. Exponential decay. Table of values again. What do we got? What's 1/2 to the -2? I hear 4. 4, 4, 2, 4. Yeah, it's 4. Thanks for that.
All right, so that's an exponential decay when b is between 0 and 1. Here's an interesting question. Does that graph have a vertical asymptote?
Yeah, it approaches. No,
Negative 3? Can I plug negative 3 into this?
No. It's not vertical.
It has a horizontal. We've established that.
There is no.
Why?
X.
You can put any value of x2 in there. It's not limited. I can go to negative 10 billion. Right? You can still have value. So keep that in mind. You don't have to, but no vertical asymptotes here, just horizontal. It would be, yeah, approach to the y.
So actually, well,
Here's another question. What if we do this? Ew. Thanks for that. How would you say that mathematically?
Inverse.
We reflect it over. Which one is it? It would do that. It's not, you see, it still has the same b value, right? So it's not going to change the y value or the over the y-axis, but we're changing it over the x. It reflects it. It makes all these negative, is what it does. Okay. All right, last one here. All right. I'm going to give you more of a real world example. So let's say a car, we have a car. How many of you have cars? Anybody buy a new car? Brand new car, anybody off the lot? Matt Cornelius. Bringing down the house. New car off the lot, huh? I've never owned a brand new car. Okay. The original price of your brand new car was $20,000. In other words, it's a tin can. Loses value. 20% a year.
Like that car has 500,000 miles in it. How much does your have? No, my car is durable. It's durable. It's been invested.
Okay, so this is some information. You're going to be working with stuff like this the next few weeks pretty regularly. Bank accounts, etc. You have a $20,000 car that loses value at 20% a year. There's the model. This is a decay function, right?
What is
Why is the depreciation the amount that's lost?
Oh, that's
It's really good for you.
T is time, even in math. Where we like to make numbers letters. What is the value of the car after 2 years? You're close. No. How do you know that? How'd you do it?
Put it in the calculator.
Explain. That's not explaining. I put it in the calculator as not an explanation.
Calculator did all the work.
Okay, so we plug 2 in for T. That's the beginning of an explanation. How many of you have got credit for an explain answer that said calculator? No. Sorry. You never will. All right, and then you do the math. You do get, hold on.
$12,000. First I put 2 for T, and then put it into the calculator. And then you press the button, it put out that number. Wow. It dropped 7,200 in 2 years.
Yes. Welcome to buying new cars. Why do I never buy new cars?
What if I buy a car this year? Give me $100. So make my car that's $5. What? 3 hours of gas is just fine. Put me up to junction.
Do you think you could graph that? Do I need to show you the graph, or are we okay? Here's the deal. My intent was for part A to be due tomorrow. The second hour gave me a lot of good reasons for it to be due Tuesday, all of it. Because they have government tests and chemistry projects, this and that and the other. But the deal was if they work hard the rest of the hour, I gave them until Tuesday and everything. Okay, so that's the deal to you guys. So I'm gonna write the homework down. If you work hard the rest of the hour, it won't be due until Tuesday. Okay? Otherwise, part A will be due tomorrow. It's up to you. Or maybe it's a government project. Okay, I got them backwards then. Well, I'm giving you a break, so if you're scamming me, that's on your own heads. Oh, that's right. You have something to do in lit too, don't you?
Not really. Well, I'm counting some hard things.
All right, there it is. I did that last hour. Yeah, thanks, Brandon.